We're going to do this division problem using what I think is the best way to divide fractions, which is division by common denominator. Some of you have seen it before, some of you haven't. That's okay. So the first thing to do is to turn both of these into improper fractions. And we're going to do that by saying, okay, how many thirds are in 4? There's two ways to do that. One is algebraically, and one is by visual model. So I'm going to show you the visual model first, and we're going to then do it algebraically. So if I have 4, it looks like my drawing tool here is going to turn them into parallelograms, and that doesn't really matter. It doesn't matter what 4. Now I want to know how many thirds there are. I could divide it into thirds. So all 4 there are now thirds, and I'm just going to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 thirds, plus I have this third that I already have. So that would be 12, and then the third that I already have, not these two, 13 thirds. That's 4 and 1/3. Turns out I can find that also by multiplying. You'll notice that there are 3 thirds in each whole one. So it looks kind of like a clock to me, but that's just how my brain works. I can do 3 times 4 plus 1. And I would get that same 13. 3 times 4, 12, plus 1 equals 13. And I still put it over 3 because I'm looking for thirds. That's the whole point. And I'm dividing that by, and I'm going to use my little clock thing here for the 5 2/3. But if I needed to, I could certainly do it using the visual model. So 3 times 5 is 15. And we have to add the other 2/3. So add 2. It's all got to go over 3. And that gives me 17 thirds. So I'm dividing 13 thirds by 17 thirds. And this is kind of a nice problem to start learning how to do division of fractions by common denominator, because we already have a common denominator. So that's kind of nice. So the great thing about this, in addition to the fact you're going to love it, is that it's just like multiplication. And division should be like multiplication because they're related. And just like with multiplication, we're going to go straight across. There's no fancy finding upside downy things, nothing like that. We're going straight across. You're going to love this. So 13 over 17 divided by 17. We're just going to write that as a fraction right now. 13 over 17. And then 3 over 3. When you have a fraction over a fraction, it's called a compound fraction or a complex fraction. Not a problem. This is a nice way to look at it. Now, What I'm hoping you see right away is our denominator right here is 3 over 3. And if you have common denominator, when you do this complex fraction, your denominator is always going to be the same thing over the same thing. In this case, it's 3 over 3. It could be 12 over 12 or 27 over 27. It doesn't really matter because that equals 1. And it's always going to come out to be equal to 1. How awesome is that? So now we've got 13 over 7 over 1, which 17, excuse me, which just equals 13 over 17, which is the answer to your question. So I'm going to rewrite that for you. 4 1/3 divided by 5 2/3 equals 13 over 17. It's always good to rewrite it like that. I know, how cool is that? And if we wanted to, we could actually take our visual model and do the whole thing as a visual model. You're like, I don't believe you. I know you don't. But right now, I just want you to suck this up and see how cool this is and how it really makes the math not a magic trick. Division is now related to multiplication because the method is so similar. And 4 1/3 is 13/3. 5 2/3 is 17/3. So relative size wise, 5 13 is 2/3 is 17. 4 1/3 is 13. So you're really just dividing 13 by 17 to get your answer. And that's what you get. So you get that relative size thing so you can see it. And you're good. I hope this was helpful. Talk to you later.